A maximum of 15.5 dBA. That's how we advertise our Silent Wings 3 140mm fans. But what are decibels exactly? And what is the meaning of the letter A? And how does the number 15.5 fit in the bigger picture? Well, as the name suggests, the decibel is a tenth of a bell, which is the official unit for measuring volume levels. But a decibel is not a decibel, there are different versions. Communication engineering, for example, uses decibel volts as a norm for line level controls. Our very own products, as well as all the other industrial goods, uses dBA as a unit, in which the A stands for the frequency filter A, included in the measuring tool in order to visualize the acoustic signals as numbers. And with this filter, you can imitate the human sense of hearing with a range from 20 Hz through 20 kHz. 0 dBA equals the hearing threshold, while 130 dBA marks the average pain threshold. There is also the frequency filter C, which is very rarely used to measure noise sources with very high sound intensity levels. And the formula with which dBA is being calculated looks like this. Okay.
It wouldn't make much sense for us to deep dive into higher mathematics now. The important thing is that this formula includes the human hearing range, with the sound intensity from the relative value of 1 up to 10 trillion. In order to avoid huge powers in numbers, these values get logarithmized so that they can be summarized on a scale from 0 through 160, for example. Which leads to a very important fact which mustn't be missed.
A decibel is not a linear value, and its quantity is not necessarily a reliable measure of volume, as this is highly subjective. For example, the pain threshold usually lies between 120 and 140 decibel and is highly dependent on the frequency mix of the sound source. This is especially true when we are talking about very low noise levels, which our products are famous for. Here you can't directly translate the decibel value onto the perceived volume, as sounds from varying frequencies are experienced very differently depending on the listener.
We painstakingly try to keep the dBA in all of our products as low as possible, but we also very thoroughly take into account the subjective sensation of sound in our test persons, which is why our products can only be produced frequency dependent. A high-pitched whistle, for example, is usually being perceived much more negatively than the pure decibel value would suggest. Also, the human ear has developed a certain sensibility for rhythmic noises like clacking bearings within fans. Also, the ear does not register all tone pitches identically. We are very responsive to tones between 1000 and 4000 Hz, which means that everything below and above these numbers is noticed on a diminished level. And it means that very low noises below 20 dBA are only audible and measurable under laboratory conditions.
Let's talk about the second important topic. Decibels are highly dependent of the distance between the source and the recipient, as the sound pressure, measures in Pascal, loses intensity with distance. There is a famous formula stating an increase in about 6 decibels when cutting the distance between the microphone and the source in half. The industry standard is a distance of 1 meter, but that is by no means mandatory, which means conversely that slightly less reputable provider can simply place their recording device 2 meters away, which would make their products 6 decibels quieter by default. So please always keep an eye on the measuring distance. It's getting quite obvious when referring to the well-known decibel chart, as it contains distance-dependent inconsistencies, which often isn't part of the equation. The famous leaves rustling in the wind, for example, are usually measured at 10 dBA, assuming a distance far away and no other sound sources. A starting jet engine produces 130 dBA at a distance of 30 meters. A solid rule of thumb is therefore 10 to 15 decibels is the sound of a person in deep sleep, which is nigh inaudible. A conversation usually runs at 40 to 60 decibels, while a jackhammer will register at about 100 decibels, all from a distance of 1 meter, that is.
The duplication of the perceived volume is directly connected to that. Regarding to that rule, many think that an increase in 6 decibels means a doubling in volume, which is wrong. What actually doubles is the sound pressure level. As we know, dBA is a technical value, not a psychoacoustical one. The accepted rule of thumb amongst acousticians is that a tenfold increase in sound intensity causes a doubling in subjective volume, which is what happens at round about 10 decibels. In order to illustrate this non-linearity, we'll use our 140mm Silent Wings 3 fan, which runs at 15.5 decibels, measured in a silence chamber. If you take the same fan in its high-speed version, also running at 100%, you will end up with 28.1 decibels. But these two numbers must not be compared in a metric system. So instead of an 81% increase, we end up with 126% increase in subjective volume.
The difference between a Silent Wings 3 with 15.5 decibels and a different one sporting 35.5 decibels is a quadruplication of the perceived volume. This is all slightly complicated, which is why there is a psychoacoustic unit of measurement called zone, which has been defined through actual listening experiments and which therefore makes the acoustic sensation more palpable. But dBA has been asserted as the industry standard for quite some time now, which makes zone more or less useless for the end customer as it lacks in comparability.
It's not unusual that your average city noise, even when filtered through double-glazed windows, brings about 30 dBA to a room, especially in combination with a heater. The Silent Wings 3 operates far below that, which is why we are using the expression virtually inaudible. On its own, the fan is hardly noticeable, but it's still making some noise, which adds to the acoustic intensity of everything else in the PC, like the noise from sources like the graphics card, the electrical whine of coils or the flowing air.
So if you put 10 Silent Wings 3 fans next to each other, you increase the acoustic intensity tenfold, while the volume only gets doubled. Which means that the fan noise in itself isn't the main problem with silence-focused PCs. So what have we learned today? Here are the 5 main insights. First, decibels are neither linear nor metrical. Second, the perceived volume is highly dependent on the frequency of the noise. When talking about dBA, one must always consider the distance to the sound source. Also, decibels must always be considered with regard to other sound sources as well as the general room volume. And last but not least, twice the fans does not mean twice the noise. Well then, stay quiet.